reason why Kubernetes is an effective solution in our context at Axon, and why we decided at a certain time to move from, let's say, traditional deployment on virtual machine to Kubernetes infrastructure. So yes, first a short introduction about myself. So my name is Adrien Peiffer. I'm 31. I'm project and technical leader at Axon in our office of Luxembourg, and I'm Odoo developer since version 7. That's all. So first, the summary of this presentation. So to help you to understand this presentation as simply as possible, I will give you a few explanations on the concept of containerized application and about Kubernetes itself. After that I will explain why we decided to move our Odoo hosting on Kubernetes. And finally, we will take a look at the different tools we use to deploy Odoo on a Kubernetes cluster. So let's go. So what? So first, the concept of containerized application, and in fact it's very simple. So containerized application are applications that run in an isolated runtime environment called containers, and those containers encapsulate an application and its dependencies. That's all you have to know about containerized application for this presentation. So now let's move on Kubernetes explanation. So yes, first here is the definition of Kubernetes from kubernetes.io. So Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services that facilitates both declarative configuration and automation. So some very important keywords here that will be discussed in this presentation. But if I simplify this a little bit to explain to you, it's basically a matter of containers running on pods. So pods is Kubernetes entity, and those pods runs on a Kubernetes node, which could be a virtual machine, for example. And the pods are executed in a context of a namespace, which is the gray box on the screen. And some pods can be accessed from inside and outside the cluster using services and ingresses. Okay, so I think you are now Kubernetes expert, so let's move on to the next part. So why? Why at a certain time we decided to move from a virtual machine hosting to Kubernetes infrastructure? For those reasons. So we want something which is portable. We want something which is available and resilient. And we want something which is secure and declarative. And now I'm going to go into more details on this point and explain what our pain points were on virtual machine deployment and how Kubernetes helped us to solve them. Perhaps a precision, so I'm not saying that Kubernetes is the only solution for this, but in our case, it's one we've chosen because mainly it's allow us to solve all this in, let's say, a simple way. So let's deep dive into those topics. So first, for the resiliency and the availability, yes, before switching to a Kubernetes infrastructure, for example, we had to plan downtime in the event of an operating system upgrade, or for other reason like applying some security patch to the machine. And it usually involves working outside office hour. And I don't know who likes doing an Ubuntu server upgrade on a Sunday, but certainly not my wife. No, just kidding. Don't error that, please. Yes, for the PostgreSQL replication, that had to be set up and maintained manually, which was not always efficient and can also be a source of errors, and the same goes for the backup configuration. For the DRP in an event of a disaster, the switchover was a manual one, involving, for example, some DNS modification, and that were not always sustainable. Yes, for the point-in-time recovery, it's more an infrastructure issue, but yeah, before that, with, let's say, small customer, we put them on mutualized PostgreSQL, and so if we have to do a point-in-time recovery on a specific database, you have to restore the whole cluster somewhere, and after that to extract the database and to restore the database on the mutualized PostgreSQL. It's because of our architecture, but also for maintenance reason. We will see after that now with Kubernetes, it's very easy to deploy a PostgreSQL cluster. So now with our architecture with Kubernetes, we basically have one PostgreSQL per client per environment. And for the replication of the attachment, this was also something that was not suitable in the sense that it was a synchronization that was done every 15 minutes, so to another server in case of a disaster. So now with Kubernetes, in fact for the Odoo web application itself, Kubernetes solves the problem by design, in the sense that if Odoo becomes unavailable, or rather if the node on Odoo is running on become unavailable, Kubernetes will automatically reschedule Odoo to another node as long as there is a node available. So let me show you a visual example of that. So this is more or less the same schema that we see before. And now let's imagine that something went wrong on a node. So we just lost a node, and Kubernetes will automatically reschedule the pod in another node. For the storage, it's a little more complex. So here with Kubernetes, for PostgreSQL, we use a Kubernetes operator, so for PostgreSQL, which is called Cloud Native PG, developed by Enterprise DB. This is the same company that developed Barman, for those who know Barman. And it's Cloud Native PG that takes care of configuring the native PostgreSQL replication, the backup, and the recovery. So it's possible with Cloud Native PG to bootstrap a PostgreSQL cluster from a repository backup. And this is it's Cloud Native PG that manages the switchover as well. So in our architecture, we have at least 2 PostgreSQL instances running on different nodes, a primary and at least a replica. And as soon as something goes wrong on a primary PostgreSQL instance, Cloud Native PG will automatically switch over and promote the replica as the primary. And when the situation comes back to the normal, later the replication will start up again to resynchronize the old primary as a replica. For the attachment part, we use cloud storage for any cloud provider you want. Or we can use on-premises compatible S3 storage. So thanks for that to the FS attachment add-on presented by my colleague Quentin this morning, which is available on the OCA to manage the storage of attachment with cloud providers. And all these components together give us a reduced recovery time and recovery point objective in terms of resiliency. So let's move on to the next topic. So it's the security. So before Kubernetes, Installation of application on servers and virtual machine was managed by our system administration team. And yeah, this is sometimes, I would say, a slowdown of the productivity and the autonomy of the project teams. In the sense that if, for example, we need to install a new application, let's take the example of a mail catcher. So if we want to check mail sent from Odoo on our test environment, so we have to ask our system administrator team to set up, perhaps via their infrastructure management tool to automate the process and to make it declarative. Or we have to request the root access to the server. It means access to firewall and so on, and yeah, opens the door to potential human error. Now, with Kubernetes, we can control the security by namespaces, and finally, a project team can be totally autonomous in its namespace, without depending on a system administrator. So finally, if you want to deploy a mail catcher, just take the image of mail.log on the container registry and push a new application in the Kubernetes cluster if we have the access right to the namespace. Kubernetes provides some multiple access level. So we have the possibility to define a role on namespace level. And we also have the possibility to define a role on cluster level, and after that apply those roles to all specific namespaces, or to cluster scope resources like nodes and namespaces, for example. In addition to that, we have, let's say, certain customers who require us to respect certain policy of security, and who ask us to ensure that all of our employees don't have technical access to their environment, but only their project support team. And so, yeah, Kubernetes make it very easy to put in place. We can also set up authentication system with Kubernetes API using OpenID Connect protocol, for example. And that's it for the security. So let's move on to the next topic, which is the declarative aspect. So yes, before Kubernetes, some configuration was not on the VCS. So for example, if I take a very simple example, so the PostgreSQL tuning, for example, so the parameter that we can put to tune PostgreSQL was done manually, and so it was not declarative. And yeah, again, if in the case of new application we want to deploy beside Odoo, either this had to done manually or by our infrastructure management tool. And again, the same for the PostgreSQL replication system, backup tuning, all had to be maintained manually directly on the virtual machine or on the server. So now we have everything inside the version control system. So we still keep the common workloads of Kubernetes in a dedicated repository managed by our Kubernetes administration team. And then we have a repository per project that allows us to define Kubernetes manifest per project. And once again, the team is totally autonomous for that. We don't use Helm chart because basically we don't need that. Instead of that, we use some standard Kubernetes manifest, and then each project team can modify them using customize. Here an example of the YAML file, so a Kubernetes manifest to set up a PostgreSQL cluster with Cloud Native PG on a Kubernetes cluster. So I will not explain all lines, but we can see it's very easy to declare PostgreSQL cluster on Kubernetes with Cloud Native PG. And so we have just to apply this file with the Kubernetes API, and we have a PostgreSQL cluster running on a Kubernetes cluster. In addition to that, if you want to configure the backup for this PostgreSQL cluster, we have to apply a new resource, which is a scheduled backup, also given by Cloud Native PG. And so we have just to push the configuration on the left of the screen, and we have the backup that are ready to be run, I don't know, every Sunday and Wednesday at 2 a.m. And yeah, we have to add something on the configuration declared on the previous slide. So we have to add on the cluster YAML file those parameters. Basically, it's just the place in which we will put the backup, so the base backup and the roles that are backed with Barman. That's all for the declarative aspect. So let's move on the next topic, which is the portability. And for that, I will take a very concrete example for that. So at Axon, we have our own Kubernetes cluster on bare metal server with micro Kubernetes distribution from Canonical. But we also help our customer to set up a Kubernetes cluster on their site. And yes, we just finalized the setup of a Kubernetes cluster on Azure EKS, which is the managed solution for Kubernetes from Microsoft Azure. And yeah, when we look back to our manifest template and look at what we had to change for the common workloads, basically we had just to change and to add some annotation to be able to add for the networking to the values given to the Nginx ingress Helm chart. That's all for the why. So now we'll check together how to deploy Odoo with Kubernetes at Axon. So yes, basically everything starts with the Git repository. So at a certain time, we decided to make a tag to push a new version. And at this point, a pipeline is automatically triggered in GitLab CI/CD. And we will use in this pipeline and on the jobs to create the image, we will use BuildKit, which is a project maintained by Docker, to build the container image based on our Odoo Bedrock image, which is available on GitHub. And when the image has been built, it is stored on our container registry on GitLab, and the CI/CD will take care of applying the Kubernetes manifest on the cluster via a GitLab agent deployed on the cluster itself. It's more or less done. So here some useful links. So you have the link to kubernetes.io, Cloud Native PG, the link to the OCA storage repository for the add-on that allow us to manage attachment on cloud provider. Yes, I forget that. So yes, we also installed the SessionDB add-on, which allow us to store the session on the database instead of the file store. The link to the BuildKit project, the doc to GitLab, and the link to our Odoo Bedrock image, which is the base image for all of our project Docker file, and which is totally generic, in fact. And that's it. Thank you very much for your attention. And now we have some time for questions.
Maybe you mentioned, but which container do you use? Is it Docker or is it LXC, or what is your favorite for Odoo?
In fact, we built the image with BuildKit. So yes, we use BuildKit to build the image.
So
And we run the image directly on the Kubernetes cluster.
So my knowledge is less than A on this subject, but I thought we always need a container like Docker to create a pod on Kubernetes.
I don't get the question.
So do we need a Docker or a container like that?
In fact, we don't need Docker in this architecture. Basically, we build the image. So we have a Docker file, which is based on the Odoo Bedrock image that provides us some possibility for to generate the Odoo configuration and so on. And after that, so the Docker file is used by BuildKit to generate the image, and the image is available to deploy it in a Kubernetes cluster. So we don't use Docker for that.
What effect did it have on hosting costs to move to Kubernetes compared to the
In fact, I would say it's more or less the same than before, but I don't know if Stefan wants to add some more explanation about the cost. But yeah, because we want to be more resilient and to make, in case of a disaster, we want to make sure that everything is good. So we have the backup, we have a replication of PostgreSQL, at least one replication. So for some customers, we have a dedicated machine which is ready to run in another region. So yeah, basically, I think the cost could be perhaps a bit higher, but I would say it's more or less the same.
Yes, in terms of resources we need for that, we need a little bit of resource to run the cluster, but it's not that much. And then with this architecture, we need a little bit more RAM than we had before, and that's mostly because we are deploying one Postgres instance for each customer, whereas before we were using a big Postgres which we shared with different customers. So it's a bit more RAM, but otherwise in terms of CPU, it's basically the same. So, and since we host most of it on our own physical servers, we can have quite high density on that. So it's totally reasonable in terms of costs, yes. Of course, if you want to go to manage clusters on Google or Amazon, it's a bit more expensive, and that you have to compare with the service you receive with that from them for managing the cluster.
Yes?
Did I get right that you manage the Kubernetes yourself?
Sorry? I don't get it.
The Kubernetes platform, you manage that yourself, you operate Kubernetes yourself, you don't
Yeah.
buy Kubernetes service from
Yes.
someone?
So we use micro Kubernetes from Canonical, so we deploy, so we use micro Kubernetes from Canonical, so we don't use any managed solution from Azure and so on. So yes, we install micro Kubernetes ourselves on bare metal cloud server and on some virtual machine.
For production workload?
Yeah, as well.
Yes, it works pretty well, and it's reasonable to manage. We do it for cost reason and also for mastering or infrastructure. But for some customers, as Adrien explained, if they choose to deploy on their own cloud, we can do it, and we do it. They just need to provide a Kubernetes access to a Kubernetes cluster where we can deploy. The way we deploy is then exactly the same, and that's also an important argument, as Adrien explained, because what we do in one environment, we can do totally or almost identically everywhere.
And basically, in addition to that, if you want, for example, at a certain time to move, because here I take the example of a new cluster somewhere, but if we decided at a certain time to move our infrastructure to a managed solution, it's also very easy because we have, in this case, to take care about the data, and the Cloud Native PG offers some solution to put in place some replica cluster, so we can basically bootstrap and start a cluster somewhere based on another cluster, and when the replica is ready, we just have to promote this one, and Odoo is ready to run with this database outside very easily. Yes? Just, yeah.
First of all, thanks for the presentation. I wanted to ask, how do you manage your environments? As in, do you treat production and staging differently? And how do your developers develop locally? Do you use the same Docker images?
No, for the moment, but we are discussing this possibility, but for the moment we developed without Docker. So yeah, we basically developed with Odoo installed locally, and after that, so we push the commit and the tags to free the version. And we deployed on staging, UAT, production the same way. We just have, let's say, two Kubernetes manifest version. So we have a test version and a production version of the Kubernetes manifest, just to allow us to test our update of the Kubernetes manifest before merging it to the deploy prod branch, I would say.
One other question. What is the way you reduce downtime when you need to upgrade the database so that the client can still access it if a database upgrade takes time?
Yeah, for the moment we don't. Yes, so the question is there downtime during a database upgrade? So do you mean a database, a technical upgrade of PostgreSQL or an upgrade of Odoo in the database? Of Odoo?
Yes.
Okay, so because Odoo is a transactional system, so here we have so technically it's possible to have Odoo running during an upgrade, but it's not depend on the Kubernetes infrastructure. Yes, we can do that so we can keep a pod running during the update of the database, but the risk is to have a transactional issue on the upgrade, as soon the upgrade will break and will start again. So yes, because in our way to develop, we use my colleague spoke about that this afternoon. We use a tool which is Click Odoo Contrib that allow us to make, let's say, some surgical updates and so reduce the downtime. But yes, for the moment, so Odoo is not available during a database upgrade from an Odoo update. Thank you. Yes. Could you repeat? Sorry, I don't get it.
The configuration you use in the Kubernetes cluster for Postgres, is this a hot standby cluster or?
Yeah. So the configuration we use for PostgreSQL is on the cluster. So basically, with Cloud Native PG, we have Postgres is running like a pod, in fact. And so we have the configuration of PostgreSQL directly inside there is a custom resource which is a PostgreSQL cluster with Cloud Native PG, and all parameters for PostgreSQL are stored in this configuration.
But do you have a project where you need a big database like that you have really to cast it and use Citus or DB? Does anyone have this in use now?
No.
Okay. This database, because currently if you have on database bot, it is the full load goes on the database. But when you have a real cluster, it is distributed over the databases in parallel. And do you ever have some configuration like this in production?
No.
Okay.
Maybe the very last question, because first in the next talk.
Is there?
Is the Postgres guaranteed to be always on the same server as the Odoo version?
No. No, there are some mechanisms in Kubernetes to give some affinities between pods. For latency reason, we usually run PostgreSQL in the same region than Odoo web application, but yeah, it could be on different servers.
Do you have latency problems with that?
No, because it's on the same region. That's why we keep it on the same region. So it's not on the same server, but it's on the same. It's not. Perhaps it's on the same server, but perhaps no. And yeah, but we use the affinity mechanism of Kubernetes to be sure that Odoo is running on the same region than PostgreSQL. So I think time is over. I have to let the mic to my colleague Zin. So thank you very much for your attention.